This is video 2-2, scientific notation, significant figures, math and sigfigs, and percent error. These math concepts are essential things that you need to make sure you understand how to do, and make sure you come back often to this video if you keep forgetting, or make sure you also get help in class too if it's something that you don't understand. So first thing we look at, scientific notation. Scientific notation, just another way of writing down numbers, but whenever you write down your values in scientific notation, it has to be in this form, a dot bbb times 10 to the y power. Now, you do not have to have 3 decimal places there, but this number, a dot bbb, has to be between a value of 1 and 10. In other words, this first value cannot be equal to 0, and you can't have 2 numbers in front of the decimal point. So let's try some examples. Write these in scientific notation. Okay. So the idea is you have to keep these digits in the exact same order, 5, 2, 0, 3, 0, 4. So it has to be 5 point, decimal point has to come after your first non-zero digit, 2, 0, 3, 0, 4. Okay. Now, what do we do next? Figure out how do you change this number that you just wrote back into the original number. So the decimal point has to end up after the 3. So that means I need to take this number and move the decimal point 1, 2, 3 spaces to the right. So that basically means I have to do 5.20304 times 10 to the third power. Okay, and that should be your answer. So try the next one. And when you do that, you should come out with 2.54 times 10 to the negative second. This one right here, a little bit tricky. We have to write the decimal point after the 1, 0.256 times 10 to some power. Now, the decimal point is after here, and then it needs to move 1, 2 to the right. So that's basically 10 to the second. But I already have a 10 to the second. Add the exponent, so that means I end up with a 10 to the fourth power. Okay. The last number, it's written exactly as it's supposed to be written, but scientific notation must have a power of 10 multiplied times that. Okay. Now, this number has to stay exactly the same, so that means I basically need to multiply it by 1, and 10 to the 0 gives you 1. Okay. You can also use your calculator to convert numbers into scientific notation for you. Okay. Sometimes your calculator has a mode on it that will change it into scientific numbers, meaning any number you punch in, once you hit the equal sign, it'll automatically change the number into a scientific notation for you. And if you need help with that, come up and see me during class. Hey, get your calculator out, and we'll go over how to actually use your calculator in punching in numbers that are written in scientific notation. Okay, so let's say we want to enter a number like this, 4.324 times 10 to the fifth power. Okay, now on your calculator, and your calculator may look a little bit different than what you see here, but the key is this EE key right here. Okay, now EE or EXP. Most of your calculators should have this button here. It may be a second function above one of the keys that are over here, but this is what you need to do. Okay, this basically means times 10 to the whatever power. Next number you punch in becomes your exponent. Okay, so in order to enter this number, I want to punch in 4.323, whoops, what was it? Whoops, 324. Okay, then the EE means times 10 to the, and then fifth power. Okay, now if I push equals, in most calculators it'll change it back into standard notation. Okay, now Why do we want to do that? Simple. What happens if we do some math like this? And some of you say, well, can't I just use times 10 and then I have a y to the x button like that? And wouldn't I come out with the same thing? Yes, sometimes. But when you start doing some math problems, if you do this 4.324 times 10 to the 5th, divide by 2.61 times 10 to the 2nd, if you do not punch it in this way, you're going to run into some problems. Okay, so let's try it, see what happens if I do it the way I'm supposed to. 4.324 EE5 divided by 2.61 EE2. And my answer should be this. It should come out to 1656.70. We'll round it off like that for now. Okay. Now, some of you may say, well, can I do this? Can I punch it in like this? 4.324 times 10 y to the x 5. Okay, and look, whoops. I still get the same answer, same number that I had before. Okay, but what happens if I do the math problem like this? 4.324 times 10 y to the x 5 divided by 2.61 times 10 y to the x 2. And do I get the same answer? This is, let's see, 16,567.049, etc. Okay, why didn't you get the same answer? Because if you do this multiplication right here, you end up not dividing by 10 to the second, but you end up multiplying by that. Okay. Also, last thing, do not do this. Do not say 4.324 times 10 EE5, because if you do that, let's clear all this. 4.324 times 10 EE5, I come out with 432.24000, which is not 10 to the 5th, it's 10 to the 1, 2, 3, 4, 5, 6. Okay, so do not ever hit the multiply sign when you're entering a number that's in scientific notation. Enter the number and then hit EE. That takes the place of the multiply sign. Okay, significant figures. Make sure you understand these concepts because these are things that we keep coming up over and over and over again. So, what are significant figures? These are all the numbers in a measurement that can be known precisely, plus a last digit that must be estimated. Okay? And when we talk about precision and accuracy a little bit later on, you'll see how this actually applies. Okay? In other words, it's all the numbers you're sure of, plus one more decimal place that is going to be estimated. Okay? Now, someone gives you a measurement, a number. How do you know how many Sigfigs are in that measurement? Okay, these are the rules. Make sure you remember the rules. First of all the non-zero digits, no matter if it's before or after the decimal places, they all count as Sigfigs. Okay, so for this one right here, we have 1, 2, 3, 4, 5 digits. So basically that means this must have 5 Sigfigs. Okay. Count all zeros between non-zero numbers. In other words, if the zeros are sandwiched between non-zero numbers, count those as Sigfigs. Okay. So, you know, same rules. You have to count the 4 and the 3, the 2 and the 3 and the 8. So that means you have at least 1, 2, 3, 4, 5 Sigfigs. Now, These zeros are also going to be counted because they're between non-zero numbers, and so is this one right here. So in other words, in this measurement right here, every digit is a sig fig. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sig figs in this measurement. 10 significant figures. Okay, if the 0 comes in front of a non-zero digit, in other words, the only time you're really going to see that is when the number is less than 1. These zeros do not count. They're placeholders. Okay, so in this measurement right here, 1, 2, 3, 4, 5, those are all non-zero digits, so you have to count those. This one right here is counted because of the sandwich rule we just talked about. These 4 zeros in the front do not count. So sig figs in this measurement, 1, 2, 3, 4, 5, 6. So this one has 6 sig figs. So non-zero digits count. Zeros, if they're in front of numbers, don't count. Zeros, if they're sandwiched, do count. Okay. Now, what about zeros that come at the end of a number? Well, if your number ends in zeros, they count if there is a decimal point someplace in the number. If there is no decimal point and your number ends in zeros, those zeros are uncertain. Okay. Now, if you see your numbers ending with zeros in the book, they do not count. So in other words, if the book says your ant gives you a number of 3,500 grams, this zero, there is no decimal point, do not count them. Okay, but in reality, they're actually uncertain. Okay. So this first example, 1, 2, 3, 4, 5 non-zero digits. This zero counts because it is sandwiched. These zeros also do count because they're at the end of the number, but there is a decimal point. So that means the zeros will count. So this one here has 1, 2, 3, 4, 5, 6, 7, 8, 9 sig figs in it. Okay. This one here, 6, 7, 8, 9, you have to count those because they're non-zero digits. These last two are uncertain. Okay. If the book told you 678,900 liters, you would say there's only 4 sig figs. Okay. But in reality, they could all these zeros could count, one of them could count, or none of them could count. Okay. So you can say, well, there is at least 4 sig figs here. If the book gives you this answer, you say only 4. Okay, how many sig figs in each of these? Okay, go through it and then check your answers. These are what you should end up with. First one should have 4. Second one should have 6. Third one should have 3. Fourth one should have 5. The last one, uncertain. Okay, but you can say, I know the 2, the 3, and the 5 count, so you could also say at least 3 sig figs in there. Okay, now, you do a calculation and your answer comes out to be a really, really long number. Okay, and you need to round off your answer to a specific number of sig figs. Okay, so let's say you came out with a really big number and someone said, well, you have to round it off to 4 sig figs. Okay, find the last sig fig in your number and look at the number after it. If it's 5 or greater, round up the last sig fig, and basically we're not going to use the rules in the book that talk about if it's 5 or greater. It depends on what the number is in front. If it's 5 or greater, round it up. If it's less than 5, drop all the digits after the last sig fig. Okay. Now, if you're dropping numbers to the left of the decimal, you have to replace them with zeros. Also, when you convert a measurement to scientific notation, the number of sig figs must be the same as in the original measurement. So, if you had a number that was 433.42 and you were to change that into scientific notation, this has 5 sig figs, your answer still has to have 5 sig figs when it's in scientific notation. Okay, so copy this down, try these, pause it, and check your answers when you're done. Okay, these should be your answers. Okay, and if you have questions with these, you need help with these, make sure you get help in class. Now, mathematical operations with sig figs. Okay, you do have a bunch of numbers you need to add together. How do you know how to round off your answer? Basically, it's pretty simple. You only round off after you're done adding and subtracting all the numbers, and then the only thing you are concerned about is how many decimal places each number had that you added together. Okay? And your final answer has to have the least number of decimal places as all the numbers that you added or subtracted together. Okay? So let's try this example. Okay? Take a look at the first one. If we add it together, this is our answer before we round it off. Now, the decimal addition subtraction rule is you look at decimal places. This has 2 decimal places, that has 3 decimal places. So my answer should only have 2 decimal places, which means I need to get rid of that one, but because it's bigger than 5, I round up to 4. So this should be 575.05. Okay. Do the same thing with the next one. Okay. But again, this one only has 1 decimal place. This one has 2, 3, 4, 5, 6 decimal places. So your answer can only have 1 decimal place. So it should be 1002.8. Okay. Now, take a look here. This number here has no decimal places. So you should be able to figure out, okay, well, right away when I'm done, I can't have any decimal places in the answer. Do all the math first, never round off before you add or subtract. But once you're done adding, subtracting, round off. So it should be 518. Now, if you multiply or divide, okay, the answer cannot have more sig figs than the measurement with the least total number of sig figs. So go back and look at all the numbers that you added and or multiplied and divided with. Count the sig figs in those. Your answer cannot have more sig figs than the one with the smallest number of sig figs. Okay, so try these. First one, you come out with that big number, plus you may have more decimal places depending on your calculator. Okay, this first number here has 5 sig figs. The second number here has 4 sig figs, and you should be able to count these by now. Okay, which means my answer can only have 4 sig figs. So I round off that answer to 46.84. Okay. Second one comes out to be 2.5527. Now, first answer has 4 sig figs. Second one, those are only sig figs that are there. You do not count the 0. So this one has 3 sig figs. So my answer should have 3 sig figs. Okay. And the last one, this one, first number, 4 sig figs. Okay. And you cannot simply write this as 1820 because you cannot put a decimal point at the end. If you do put a decimal point at the end, that means the 0 would be a sig fig, and that would mean this would have 4 sig figs. But the answer we just said can only have 3, so we have to write this number in scientific notation. Okay, if you have a whole bunch of adding and subtracting, perform all the operations first. Don't add and then round off and then add and round off. Do all your addition, subtraction, and round off when you're done. Same for multiplication and division. Okay, try these, pause the video, and then check your answers again. First one, that's what you should come out with before you round it off. Once you round it off, you should come out with 318. For the second one, that's your answer before you round it off. Once you round it off using the decimal place rule, because this is addition and subtraction, your answer should be 4.1. Okay, now what happens if you have to add a bunch of numbers and multiply, or you need to multiply a bunch of numbers and then add or subtract something from it? Okay, do all your dissimilar operations first, and then, or do all your similar operations first, then if you go to a dissimilar, round off before you go to the next operation. Okay, and use the rules for rounding off from the last operation you did. So try something like this. Okay, pause the video and check your answers when you're done. Okay, this is what you should have from the division part before you do the addition. Round off. Now add, and then finally round off using the addition rule. Okay, try this one. Again, pause the video. Okay, this should be the result of your addition. Next thing you need to do is multiply, and then because dividing is a similar operation, you do not need to round off. Okay, but again, before you multiply, you need to round this number off using the addition rule. Okay, and you should come out with this. Okay, last thing we look at, calculating percent error. Sometimes when you do a calculation, there is a correct answer that was expected. So, depending on where you got your answer from, if your answer came because you're doing lab experiments and plugging in data, you can end up with a certain percent error. Okay, so percent error follows a really simple formula. Okay, your percent error, you have to know or be told what the correct value is, the accepted value is. And your experimental value is basically the one that you found. If you did a lab, this is where the value comes in. And then take the difference between those and divide by the accepted value, multiply by 100%. Okay. You can have positive or negative values depending on if your number was bigger or smaller than the actual value. And a good percent error, general rule of thumb, unless you have really, really large values, is 5%. So here's your review question. How many Sigfigs are in this measurement? 0.00250,640 liters. Is it 6, 9, 5, 4, or uncertain?